So if you followed the advice in the previous lesson, you will have had a look at some of these drawing tools in more detail. For example, you might have had a look at the Polystar tool and tested out the options and changed the number of sides, and then tested it and found you can make all kinds of different shapes with that tool. I just deleted that. You may also have looked at submenus, for example this oval primitive tool, which you can test out some options here to see what they do. Make some interesting effects with it. Again, I'll just delete that. So if you haven't done that already, I suggest you have a look at these tools in more detail to make sure you're familiar with them. Because when you are, you can make quite sophisticated drawings, such as this wheel. And in this lesson, I want to show you how to animate this wheel using stop motion animation. And this form of animation is similar to something we've seen before, which is animating a button. If you recall, an animated button has 4 frames across the top: an up state, an over state, a down state, and a hit state. And the hit state, as you recall, was where you defined an area for the cursor to activate the button to change it from the up state to the over state. And when you clicked on it, it would go to the down state. Stop motion animation uses the same principle. It uses several different frames, each time with a gradual change in that frame to create the illusion of movement as the frames are played one after the other at a fast speed. So, as you recall, to create a new frame, you right mouse click on the next frame and click on Insert Keyframe to copy the contents of the previous frame into the next frame. And then you can modify the appearance of the next frame so that you create this gradual change to create this illusion of movement. So I'm going to adjust the rotation of that wheel, and I'm going to use the transform menu rather than the free transform tool which I showed you in the last lesson. And the reason for that is that you can make more precise changes. So I'm going to make a 5-degree change in each of these frames, and in doing so I'll get a gradual kind of rotating wheel effect. So if I go back to frame 1 and press enter, you can see the beginnings of an animation there. But of course a wheel doesn't usually rotate around a fixed point. It usually moves forwards as it rotates. And you can either guess the amount it moves forwards, and then you would change the X position at each frame by your guessed amount, and you could try different values until it looks like it's the correct amount. Or you can use a mathematical formula to link the angle of rotation to the amount the wheel moves. And if you use maths, then you will get a more precise looking animation, a more realistic animation. So I'll show you an example of how you would go about calculating this particular relationship. So here's the wheel, and you may remember from your maths lessons from school days that the circumference, which is the whole length of this circle, is the same as 2 pi times the radius of that circle, which is the distance between the edge and the centre. And we want to find out how far the wheel moves forwards, and that distance is the same as the distance of the arc that the wheel moves through when it moves through the angle. In our case it's 5 degrees. So it turns out that this is a simple proportionality relationship. If you can find the proportion of this angle relative to the whole angle of a circle, which is 360 degrees, then you can also find the proportion of this this arc relative to the whole circumference. So if we divide A by 360 degrees and then multiply that by the circumference, we get the arc. And the arc is the same as the distance that we want to move the wheel forwards. So that's how we calculate. That's how we find this mathematical relationship. So if we put the numbers in, our wheel has a radius of 115 pixels, and I'll show you how to use Flash to find that in a minute. So we're rotating it by 5 degrees each time, so the numbers we want to use is 5 divided by 360 times 2 times pi, which is 3.14, times the radius, which is 115, and that turns out to be 10 pixels that we need to move our wheel through in each frame. So I'll show you now how to find the wheel radius. So our width of the wheel, we can see here, is 230, although it's quite deceptive because this wheel is a symbol and it's a rotating symbol, and the width is the width of the binding box along the horizontal plane. So if you looked at frame 4, the width of the symbol is the distance between this corner of the binding box and this other corner of the binding box along that horizontal line, which is 281 rather than in the first frame 230. So if you're looking at the width of a rotating symbol, you should actually go inside the symbol to look at the graphic itself. You can either double click on the symbol on the stage or double click on the symbol in the library, and you'll see that the symbol name comes up next to scene 1. And now if you click on the graphic, you'll see that the width is 230, which is the diameter of the circle. The radius of the circle is half that, which is where I got my 115 pixels from. So that's the first pitfall, finding out the radius of your rotating circle. There's another pitfall, because we now want to move this wheel 10 pixels in each frame. So let's have a look at our X position. This is the value we want to change. So in the next frame you think I want to make it 160, the frame after 170. So let's have a look at frame 2. In frame 1 it was 150. In frame 2 it's already over 160. And in frame 3 it's over 170. So it looks like the X position of this wheel is moving, even though the wheel is actually staying in the same position as we've seen before. If I press enter, it's just rotating around that static position. So what's going on here? What's happening is the position that is being registered is the place where you can see this cross here. That's the registration point of that symbol, and that position is rotating about the rotation point, which is in the middle of the wheel. And you can see as the wheel rotates, the registration point is moving, and that's why you get this changing X position even though the wheel is actually staying in the same place. So how are we going to fix that problem? What we really need is for the registration point to be at the same point, the same place as the rotation point. So I'm going to delete the animation I've made so far by going right mouse click and remove frames, because it will get awkward otherwise. I'm now going to go inside the symbol, and I'm going to move this wheel so that the centre of the wheel is over the registration point. So as it rotates, it should rotate around the 0, 0 point of the symbol, which is how the flash knows where it is on the stage. So inside the symbol it's 0, 0, but outside the symbol, that 0, 0 point of that symbol is actually not 0, 0, it's 115 by 85. So each symbol has its own kind of x and y axis. So if I'm clicking on this wheel, you'll see it's 0, 0. So how do I get that center point of that wheel over the 0, 0 point of this symbol? Well, the easiest way is to go to the Align menu and to use Align Horizontal Center and Align Vertical Center. So that wheel graphic is now over the 0, 0 point, the registration point of that symbol. I'll go back to scene 1 now. You can see it's actually moved on the stage as well. So let's move this back. So I've moved the wheel now. So the registration point is at the middle of the wheel. But if I try to rotate this, I'll use this free transform tool to show you. If I now rotate it, it's now rotating around that corner, which is not what we want. I'll just undo that so it goes back. So it's rotating around the where that O is, and if you use the free transform tool, you can move the position where it rotates around. So it will now rotate around the middle of that wheel because I've just dragged that over. So let's have a look at that in action. Let's have a look at that in action with the rotate tool first. If I rotate the wheel now, you can see it's rotating as you would expect it to. So that's the other pitfall to fall into with when you're animating with rotations. You've got to be very careful about where the registration point of your symbol is and where your rotation point is as well. And generally you want your registration point and your rotation point to be in the same place, although not always. It's entirely dependent on how you want a particular symbol to rotate. So let's put in our frames again and add our rotation back in. So I'm going to put 5 in again, then right mouse click, insert keyframe, and then put 10 in, and then right mouse click, insert keyframe, and then 15 in. If I go back to frame 1, it looks just exactly the same as what it did when I started. But now if you look at the X position, it should be the same each time. It's 266.1 in every frame. So it's no longer changing with the rotation, it's always in the middle, which means I can now go and increase my X position by 10 each time, which is what I calculated I needed. So 10 pixels because it's rotating by 5 degrees. This one needs to be 280, and this one needs to be 290. So let's go back to our first frame, and it's looking like it might work. So here's one I made earlier, and we'll be able to see that it does in fact look realistic. So in the next lesson I'll be showing you an alternative type of animation to achieve the same effect but with less work, which is called tweening.